Alrighty, boys and girls, welcome to our next this seemingly endless series of lessons on circles. 10-6. Circles. 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 Oh, circles. Alright, what we're talking about in today's lesson 10-6 is angles and circles. And the first type of angle in the relationship with circles are angles that are inside of the circle. Angles inside the circle. Type 1. The first one you already know about are central angles. Central angles certainly have their vertex inside the circle. And you know that because the vertex is right at the center of the circle, hence the name central angle. It's amazing how that works. Central angles have their vertex at the center of the circle. The measure of the arc is going to equal the measure of the central angle. So, for example, if measure of angle ABC is 40, then the measure of arc AC is also 40. Likewise, if we go the other way, which we can, if the measure of arc AC is 30, then my central angle is also going to equal, let me get my marker back, 30. The other type of inside angles is called a chord angle, or if you want, a chord angle. So we have two chords. These two chords, they intersect right here, not at the center. They're not central angles. Okay, so they just intersect anywhere inside the circle. The measure of my angles, measure of angle A and B, so this angle right here, is going to equal the measure of angle DMC, of course, because those are vert angles, those are vertical angles. These two angles are going to equal, and they are going to equal the measure of the average of the arcs. So you take the two arcs, and I'll just put those in red, this arc plus this arc divided by 2. So if measure of arc AB is equal to 30, and measure of arc DC is equal to 40, then these angles, both of these angles right here, they both equal the same thing. They're going to equal 30 plus 40, all of that divided by 2. 30 plus 40 is equal to 70. 70 divided by 2, of course, is 35. Please do not cancel terms. You could not cancel the 40 with the 2 and get 20, because then your answer would be 50. And we know our answer needs to be 35. So again, just to reiterate, that means to repeat in Spanish, reiterate. To reiterate, our chord angle measures, if the chord angle is always going to equal the average of my two arcs. So its arc, we'll call one arc X, the other arc Y, and divide that by 2. Or if you prefer, 1/2 the sum of the arcs. So as we look right here, real quick, this is 80. These two angles are both 80 because 40 plus 120 is 160. 160 divided by 2 is 80. These angles right here are 50 because 80 plus 20 is 100. 100 divided by 2 is 50. And these two angles right here are both 95 because 120 plus 70 is 190. 190 divided by 2 is 95. Okay, let's try this one. Let's solve for x. Be careful here. X is not a chord angle of the given arcs, okay, because my arcs are right here in blue. This arc is 96 and this arc is 46. So actually I can find these two chord angles real easy. So I'll just call that y. So I know now that y is equal to 1/2 times 46 plus 96. 46 plus 96, don't tell me, is equal to 1/2 times 142. Half of 142 is 71. So if this angle, we'll do this in red, is 71, I think x is going to equal 109, PT 109. If you email me with the answer to what the PT 109 is, I'll give you a bonus point. Okay, let's solve for x right here. I now know that I have a measure of an arc is x. I have a second measure of an arc is 100. And I know that the chord angle is 70. So I now know that 70 is equal to 1/2 times my first angle, which is x, plus my second angle, which is 100. 100. Okay? Now to solve this for x, I'm going to multiply both sides by 2. So on the left side, 70 times 2 is 140. 1/2 times 2 is just 1, so that goes away. I'm left with x plus 100. Subtract the 100, x equals 40. So the measure of this arc right here is 40 degrees. Okay, you guys try this one right here. Solve for x using your chord angles. Give it a go, give it a go. I'll be right back. I'm going to go grab a cup of water. I'm thirsty. Water is delicious. So, I got x equals 19. What did you get? What I did is I said my chord angle, 76, is equal to 1/2 times the sum of my two arcs, which is 5x plus 2 plus 3x minus 2. Me personally, I don't want to work with fractions. I multiply both sides of my equation by 2. 76 times 2 is 152. 5x plus 3x is 8x, plus 2 minus 2 goes away. The 1/2 times the 2 went away too, so 8x is 152 divided by 8, x equals 19. How'd you do? You got it, yeah. Give it a go, folks. See what you do. How did you do? See what you do. Give it a go. Okay, I got x equals 20.5. I set my chord angle, 2x minus 5, is equal to half of the sum of the arcs. Well, the arcs are 42 and 30. 42 plus 30 is 72. So 2x minus 5 is equal to 1/2 times 72. Half of 72, of course, is 36. Add the 5. 2x is equal to 41. Divide by 2. X equals 20.5. Okay, type 2. Type 2. The vertex of my angle is on the arc or on the edge of the circle. There are two types of these. Two types of type 2. All right. Okay, the first type is easier to see. We call this an inscribed angle. An inscribed angle is an angle whose vertex is on the edge of the circle and it passes through the circle then. So, angle XZY is an inscribed angle. The measure of the angle is always half, so this angle is always going to be half of the measure of the arc. So in other words, real simply here, do this in green, if this is 2x, if that arc has a measure of 2x, the angle has a measure of x. So, if the measure of angle XZY is 40, so if this is equal to 40, then the measure of the arc is going to equal twice that, which is 80. Or we can go the other way. If the measure of the arc is 100, the measure of the angle is going to be half of that, which is 50. All right, the other type of type 2 angle is called the tangent chord angle, and this, I will admit, is tough to see sometimes. A tangent chord angle, again, you can see now the vertex is on the edge of the circle, but half of the angle is a chord, or a chord. Chord, so much more fun. Half of the angle is a chord, and the other half of the angle is a tangent. So we have a tangent chord angle, and again, this angle right here is going to equal half of the inscribed arc right here. So the angle right here, is going to be half of the arc. A tangent chord angle has a measure equal to half of the inscribed arc. So as we're looking at this guy right here, this is a tangent chord angle. Here's my chord. Here's my tangent. Notice my vertex is on the edge of the circle. So this angle is equal to half of this arc. It's equal to half of the arc. Or if you prefer, the arc is equal to twice the measure of the angle. Okay, that says that right there. If measure of angle ABC, so if this angle right here is 120, not drawn to scale, this arc would then be twice that, which is 240. Or if the arc, and this looks more like it, if the arc, let me switch colors, is 120, if that arc is 120, then my angle right there is going to be 60. Okay, let's solve for x. Not much of a problem, but do we recognize that x is the arc of a tangent chord angle? Here's my tangent. Here's my tangent. Here's my chord. This arc is going to be twice the length of the measure, or twice the measure of my angle. So therefore, that arc is going to have a measure of 80 degrees. 2 times 40. Yup. You guys try this one. Give it a go. See what you get for x. Okay, so as you look right here, this arc is 240, which means the remaining part of the circle must have a measure of 120. Okay, that's the intercepted arc of this chord tangent angle, my tangent chord angle. So x is going to equal half of 120. X equals half of 120. X equals 60. All right, type tree, outside. The vertex on my angle is outside of the circle. Swikle. Let's just review these words real quick. A secant is this red line. It intersects a circle at 2 points, 1 and 2. 1, 2. This red line is a secant. This green line right here is a tangent. It intersects a circle just at 1 point right here. It just gives it a kiss. It just touches the circle, just gives it a little peck. Just gives the kiss right there at 1 point. There are 3 types of type 3 angles where the vertex is outside. The first one is the secant. The second one is the secant tangent. And the third one is the tangent. It's amazing how we name these things, okay? But the formula for all of these things now, the measure of my angle, let me get my marker, the measure of the angle is equal to 1/2, not the sum of the two arcs, not half the arc because there's 2 of them, but 1/2 the difference of the 2 arcs. So as we look here, we can see now this angle is 50 because it's equal to half of 140 minus 40. 140 minus 40 is 100. Half of 100 is 50. This angle is 60 because it's equal to 1/2 of 160. 160 minus 40 is 120. Half of 120 is 60. And looking here at the tangent, one arc is 260. The other arc is 100. 260 minus 100 is 160. Half of 160 is 80. So in the secant, remember a secant angle is equal to half the difference of the arcs. And here we have a secant and a secant. Notice that this is a type 3 angle because the vertex of the angle is outside of my circle. So this arc minus this arc, those measures, this minus this divided by 2 is going to equal the measure of my angle. So what I'm going to do here is I'm going to label measure of arc AE is 100. Measure of arc BD is 40. So therefore now my measure of angle C is going to equal 1/2 times 100 minus 40. 100 minus 40 is 60. 1/2 of 60 is 30 degrees. In the secant tangent, again, the secant tangent angle is equal to 1/2 the difference of the arcs. So this arc minus this arc, this minus this divided by 2 is going to equal the measure of my angle. Measure of angle O equals 1/2 arc MP minus arc NP. So let's label. Arc MP is 120. Arc NP is 30. So measure of angle O is equal to 1/2 the difference of my arcs, 120 minus 30. 120 minus 30 is 90. 1/2 of 90 is 45. And the last of our type 3s was the tangent-tangent. Tangent-tangent angles are equal to 1/2 the difference of the arcs. And again, we basically have a major arc and a minor arc because it's the whole circle. It's the whole swiggle. Okay, so measure angle y is equal to 1/2 the major arc minus the minor arc. So if major arc xz is equal to 100, if minor arc xz is equal to 100, and again, if it doesn't tell us exactly, we assume the minor arc, right? So minor arc xz, I'm getting my marker here, we'll do this in blue, is equal to 100. That means that the major arc must be 360 minus 100, which is 260, because the total circle has to add up to 360. So now my angle is going to equal 1/2 the difference of my arcs, which is 260 minus 100. 260 minus 100 is equal to 160. 1/2 of 160 is equal to 80. Measure of angle y is equal to 80. Okay, why don't you guys try these? Solve for x in both of these problems. These are both type 3 angles. This is a tangent secant angle. Notice our vertex is outside the circle. Here our vertex is outside the circle. This is a secant angle. Go ahead and solve for x on both of these, and I'll come right back. Go get a little more water. Okay, for the first one, I got x equals 38. That was the measure of my tangent secant angle. So the measure of my angle is going to equal 1/2 the difference of the arcs, 178, minus 102 is 76. Half of 76 is my 38. And in the second one, I'm looking for this little arc right here. I know that my secant angle, 68, is half of the difference of the arcs, 158 minus x. So 136, I multiply both sides by 2. So 68 times 136 is, 68 times 2 is 136. And that's equal to 158 minus x. I moved my x to this side, subtracted the 136. X is 22. Okay, last thing you need to know, the sum of the measure of a tangent-tangent angle, we'll call that right here, x, and its minor arc, 122. X plus 122 will always equal a 180. Okay, so this angle plus 122 will always equal 180. If you stay with me this long, send me the answer for x and I'll give you a bonus point. First 5 people to send me the answer for the measure of angle P get a bonus point on our next test or quiz. That's it, folks. Adios. Have a great night, and we shall see you mañana.